Hello, welcome back to Blender Sushi Live Noding. Today I'll be doing something that's slightly a little bit more relaxing and fun. I'll be just going through how we could set up something like a Stacko blocks in Blender. It's actually kind of also like a classic um, example. It's a good exercise if you're doing like a node base and then you're just starting to use Sverchok or animation nodes, it's a good idea to try to create this kind of stack. You will definitely learn quite a bit of things and some concepts. Yeah, so if you're trying to do that using Blender on like a modeling, you probably will start with a cube and then you scale it down, and then probably you're in edit mode and then you scale it in X and then scale it in Z, and just to get the first block. You can get more details for each blocks, but I guess for what we're doing we don't really care too much about that bit. Anyhow, you probably, if you know arrays, you can probably use array, or maybe different method. You're using like a dupli, Blender dupli face or dupli vert, I guess, or you can use particles as well, but that's might be um, not the way to do it. It's but you can. Um, yeah, if you're doing it manually, you probably want to join this guy, Control J, and then use array. Like the usual stuff. Um, and I'm using the locator for the object offset, and should be that should be 0, and then the array can go up, and I can rotate it in Z here, and then I'll probably edit this shape so it looks a little bit more like a squarish. Yeah, I guess something like that. Did I? And now we can increase the count. Looks like there's a scaling happening, which is weird. I didn't scale it here. Fix scale. Anyway, just. Oh, actually, because we have that 1.3, just apply the scale. Now we have something that looks a bit like pyramid. But it's a cool thing you can do with array. Anyway, for our stack object, that's what this is how you do it manually, I guess. You can have a stack of 12, and then once you're done, you want to do like a simulations. So you have this. I just did an apply on the modifier, and now if you wanna some simulations, you will be doing something like this. I'm gonna create a floor real quick. Scale it. So this guy is gonna be rigid body, passive, and this guy is gonna be rigid body active. But then, okay, I just made a mistake there. I shouldn't do that. I should separate the blocks first. Separate the blocks by loose part, and then for each one of them, I will have to set origin to geometry, and now we can use the physics tab here. Just add active and just play it back, and then there you go. So you got it, and then you have the simulations, and then you can play around with the simulations like that. Yeah, so it's a fun stuff, and definitely something you will do at some point. So if you're doing it using animation nodes or Sverchok, I already prepared like a finished version, because it might take too long if I have to do it from scratch. I have 3 different methods. I start with a Sverchok one, Sverchok stack. Okay, so that's what I have. I think, yeah, I think this should be 90. So with the Sverchok, actually, just like doing it manually using Blender, I start with this box. Sverchok itself has its own box generator, if you want to use that. What I did was, so first, okay, Sverchok. Here I have the list join. Yeah, and I have this 1, 2, 3, 4. How come I have 4? I should have just 3 objects. Oh wait, that's for the rotations. That's silly. Okay, save this. So list joins. I have these 3 different vectors, list of vectors. It's 3 for the elements of the blocks, which is the one at the bottom there, the base. And then I join the vectors, and then I put it into matrix in, and I didn't rotate it. And then I use the apply matrix as a mesh. So I actually join these 3 blocks, and I need to use list repeater in order for that to work properly. And then I have another apply matrix and join them with the base element created. It's easy, as it's just a matter of just duplicating the elements, and then rotate it 90 degree, and yeah, so that's what I did. So it's kind of two steps process, and yeah, so you either join it or you don't need to join it. So here I can, if I want to keep the orientation of objects, I don't need to join and turn it into a single mesh. I could just probably just do it like this, and then if I bake, and since this is Sverchok, we have to bake. That's what we got, and then you can do like, see, this is like a joint. We can separate the loose part, and each one of them, let's go to object mode. So each one of them still have orientations, correct? Orientation, it probably doesn't matter too much if you're doing a rigid body simulations, because eventually we're just gonna turn this into active rigid body. Yeah, with Sverchok, I don't think we can make that active automatically. Probably you can using script node, but I'm not gonna do that. And then I actually use animation nodes. With animation nodes, I have two different ways to do it. The first one is this, where it's similar to Sverchok. I start with I believe I start with an object. Let's see. So I start with a cube, and I instance it 3 times, and then I use this mesh data, and also similar to Sverchok, but here I'm using line, and then with a 3 subdivision of the line, and I get the vector, and then using the matrix I arrange the duplicates. Once I did that, I actually here I'm joining it as a single mesh, similar to Sverchok. Okay. Then once I get the base object, I create instances to duplicate up, and then I join it, and it's also becoming a single objects like that. So the nice part about animation nodes is this kind of simplicity, where in the end you have just the duplicates, and then you can transform each duplicates and randomize it slightly. This part is really simple. I like it. With Sverchok, you kind of if you understand really well what's going on, Sverchok can do a lot of interesting manipulations underneath, like in the mesh, inside the mesh. Sometimes it can be difficult to think of, but once you get it, it's actually really smart. But I have another setup with animation nodes here. That's the final setup, similar to the other one, except that near the end I add some colors, and then I also make the active rigid body apply for each object, so it's kind of automatic. Let me review this again. So start from the beginning. Here I'm actually, instead of joining the mesh, I actually just work on the I use lines, and then yeah, and I duplicate the lines, and I turn the lines into like points for the placement of the blocks. And the only things that's a little bit mathematical is how I kind of rotating the objects manually in the end. I mean procedurally. So this is a tricky part, because if I don't do this, because I'm just referencing the points from each lines, I actually lost the directions for the blocks here. Let me quickly display that. I need to turn on always. So this is 111,000, 111,000. Whatever is 111 means it's rotating at 000, I guess. No, it's a 111 means it's rotated 90 degrees. So we have kind of pattern here by using this formula: index //3 modulus 2, and yeah, other than that there's nothing really complicated here. Here actually, see, without that rotations we have that kind of structure. With the rotations we have the thing working. Just now we lost the coloring, I guess. Maybe it's just a Blender and the recording. I have to turn off Safari, I guess, slowing down everything. So Blender might crash. No vertex defined. Convex hull. Okay, Safari is off. Let me open. So we got everything working, and if I want to give a demo, it's looking like this. The stack we can control. The rotation, I think I slightly make variations a little bit just to make it looks nicer. And then okay, let's see, that's the floor. I want to move the floor slightly. No, see, I cannot select the floor. Anyways, hide this. Hide this guy. Hide it. Okay. So this is what we got. The simulation is actually working, but maybe the recording or something is okay. Yeah, so as you can see, we can make adjustment to this UNO Stacko, and it will update right away. So if I make it like 10, maybe I'll just delete Suzanne, make it 12, and maybe it's a little bit faster now. Oh yeah, so it's almost like real time. I probably need to cache it or something, but as you can see, it's working. And then perhaps if I set it up properly, we can. Oh, it's kind of okay, spawning the blocks as I increase it while the playback is running. So this might be a cool effects to have. So it's quite interesting. So I keep generating the blocks while the simulation is running. We don't know how it's gonna end, but if I keep increasing it, so it will generate 3 blocks for every input. Yeah, so that's really quite fun. Really, in reality, you will probably you have the setup like this, and then you cast the simulation. Let me try doing that. Compose back to compositing here. Wonder why I cannot select the plane just now. So that's the original blocks. This is our thingy. Here I made the blocks passive while the copy is active when it's got generated. This is what I did. So maybe I can just bake it all. Bake all. Developer. Bake to keyframes. Let's try that. Seems to be doing the simulations. That's probably more correct and accurate. Should have made the floor slightly larger. let's see if I can stop the baking. Okay, I did. So it's not really keyframing the objects. This is a simulation, so let's see how many frames I have. 300 frames. Let's bake it. Make the floor slightly larger. Go to edit mode and then see that we have a way to scale this. Is it Alt or Command? Shift. Okay, Shift and scale like that. And for these guys, rigid body dynamics. Rigid body cache, bake all dynamics, start and end. Okay, let's end it around 200. Okay, it's baking. We're just gonna wait. Coin cache. Oh, it seems to be working. 16, 17 frame. 20, 21. Just gonna wait. You could, of course, at any point, kind of model the blocks. Just have blocks that's have more details. But the simulations and the setup, the procedural setup will take care of that later on. Yeah, of course, you don't need the high-res blocks to do the simulations, and that's actually the main idea of procedural. I guess eventually, when we have like a node-based Blender particles, and for simulations, this is gonna be a lot simpler, I guess. But still, if you want, this is a good start for you to learn, like the procedurality of workflow. Yes, so we have 83 frames in memory. It's taking quite a while, so I'll just kind of cancel it and then see what we got. Yeah, okay, that's quite nice, I guess. And you can scrub it, of course. Yeah, so and you can of course use like another objects to hit this UNO stack or tower, and yeah, so that's really fun, and you can of course change the setup at any point. So let me show you the node 3 once again. So here we go. Where did I start? I start with a line, and then I output the line as a mesh, and here I actually create a loop, and then I did the rotation here, and the result is already just the lines being stacked like that, kind of like the array. And because each line has like a 3 points like that, we can simply replace the points with the box, and that's exactly what happens here. Even though it's a bit complicated here, this is the how many stack of blocks we have. 55 goes into the loop. Let's data continue on. See here, I'm getting the each of the lines points, and then just instance the cube for each point. And then we have this funky expression for the rotation, combine Euler. I have a little bit of randomization. Here the color, I randomize the color for each block. And here finally I just put everything under one group, rigid body world. So with this setup, each object is still separate objects. I didn't combine it into a single mesh. That's why everything works right away. So you just give this control to animators. Okay, animators, here's your UNO block, and just set it up to any number you want, and then you will have the animation ready, just like that. Yeah, so hopefully this video tutorial is useful for you. Thanks again for tuning in and for subscribing. I'll see you next time.